Hi, everyone, and welcome to Feed and Grain Chat. I'm your host, Elise Schaefer, editor of Feed and Grain. This edition of Feed and Grain Chat is brought to you by Interstates. Located in Sioux Center, Iowa, Interstates offers electrical construction, electrical engineering, and control system solutions. For over 70 years, they've been tackling complex challenges and developing innovative solutions for industrial manufacturing and processing clients around the world. Interstates brings their clients a breadth of experience in the feed and grain industry, from greenfield sites to supporting existing facilities with upgrades, service calls, and ongoing maintenance. Contact Interstates to learn how you can partner with them on your next project. Today, I'm joined on Zoom by Adam Dittbenner, Instrumentation Manager for Interstates. He's here to cover the basics of NFPA 70B, a new electrical preventive maintenance standard, and help facilities prepare for compliance with it. Hi, Adam. Thanks for joining me today.
Yes, thanks for having me.
Absolutely. Well, let's start by telling us about the testing standards and requirements under NFPA 70B.
Yeah, so there's new standards, new requirements regarding NFPA 70B. And these are all really in regards to the testing of electrical equipment inside a processing facility in order to ensure safety. So with that, NFPA came out with a new standard for 70B, not to be confused with 70E. This is 70B, which is the maintenance standard for electrical maintenance. And the standard covers preventative maintenance for all electric communication systems and equipment. The purpose of the standard is to provide practical safeguards for persons, property, and process from risks associated with for a breaker or malfunction. The standards for equipment typically found in industrial plants. We often get the question, who does this apply for? Who should be paying attention to this? Per the standard, it says it's for industrial facilities, commercial facilities, institutional facilities, and even applies to multifamily residential complexes. What's not typically covered by this would be consumer appliances or equipment intended primarily for home use. So really, any larger facilities out there this covers, not necessarily meant for home use electronics or residences.
Okay, so what is the scope of this testing and the required frequency?
So there's several tables within this standard that give kind of the groundwork of what to test and when to test. If you were to look it up, there's a good table within there, table 9.2.2, and it'll actually go down and it'll list all the different pieces of equipment in a facility covered by this. A lot of the things included are transformers, busway, GFCI's grounding, lighting, breakers, which we'll talk a little bit more about later, motor control equipment, panel boards, cables, goes as far as power factor correction, cabinets, rotating equipment such as motors, UPSs, a few of the things all mentioned within that. And then expands beyond that and says, well, here's the things to check. Here's what to check. It includes visual inspections. It includes cleaning, getting the dust out of this equipment. It includes mechanical servicing when fixing any broken or worn parts. And then it also includes the electrical checks for each of these devices, which again, we'll talk a little bit more about here in a little bit. But within that table, it also calls out the frequency of how often to check these things. These aren't things you need to check all the time or every month, but there's a certain cadence of years associated with performing each of these checks. The range is anywhere from 1 to 5 years, and it's based on the piece of equipment. And it's also based upon the different conditions that the equipment falls into. NFPA calls out 3 different conditions that the equipment could fall into. Category 1 is basically anything that's new, freshly installed. Category 2 is something that's been in service but's maybe had issues in the past. Finally, Category 3 is anything that's been in operation for quite some time, has had issues, or hasn't been checked in a long time. More specifically, it hasn't been checked within the periods of checking it called out. So an example of that might be if you have some breakers, per se, and these breakers haven't been checked in the last 5 years. Well, they would be moved to Category 3, whereas to check them every year, just because they haven't been checked for quite some time. Other things such as IR scanning is something that it calls out as getting checked quite frequently, anywhere from a half year to every year for doing IR scans.
Adam, what equipment and techniques are used to conduct this testing?
We'll hone in on just some of the equipment and techniques used for breaker testing alone. And where we get these things that need to be done for checking breakers is, again, another table within NFPA 70B. If you go to table 15.3.5, it lists the items to check all molded case breakers, insulated case breakers, and low voltage power circuit breakers. Kind of the three different types of breakers you might have in low voltage. And when I say low voltage, I'm talking anything 600 volts and under. So most commonly in the plants we're working with, we're talking breakers on 480 volt equipment. Out of all those breakers, the most common breaker you'll likely find is molded case breakers, but each one of them is called out as needing to be checked per the specs in this table. So we know we got to check breakers. What do we got to check on these breakers? Well, there's a couple handfuls of different items that this table calls out for checking. The first thing is insulation resistance testing, or megging is the common industry term for it. And that just is an electrical measurement that helps to ensure your phases don't have any potential shorts to each other or to ground. Literally checks the insulation of all the components within the breaker. The next one is digital low resistance testing. Imagine just a really small amount of resistance or ohms across the contacts of phase A, B, and C. That's what this is for. Is make sure you got good contact within your breakers. To make sure there's not some corrosion there or some dust there causing a large amount of resistance. Because when you have resistance and electricity flowing through it, you've got heat. And that's one of the main reasons of equipment damage or incidents. So we got the MIGing, we got the low resistance testing or the DLRO. We got the IR scanning, the infrared scanning. That's useful for helping to detect those hot spots, either on the line side or load side of your breakers, infrared camera to detect those things. When you do perform work on the breaker, you bring the plant down, you clean the breaker, you exercise the breaker, which is just opening and closing the breaker several times to exercise those springs and moving components inside the breaker. And then finally, you do the breaker testing, which is literally running amps through each of the phases of the breaker and recording the amount of amps and the amount of time it takes for that breaker to trip. This involves could be up to a couple handfuls of tests, just testing the different set points within the breaker, the short term, the long term, the instantaneous, and the ground fault breaker settings. These are all basically different settings in a breaker that help it know when it should trip or determine when it should trip. So testing each of these to see what they're tripping at is good to do and called out by the spec as well.
So once this breaker injection testing is complete, how are the results interpreted and how should managers act upon them?
Yeah, so each of those tests I just talked about can give a plant a good idea of whether the breaker's good to go and ready and good to be used for another year or 5 years, or if it maybe needs replacement or fixing. What those results are is a matter of ohms. For insulation resistance testing and contact resistance testing, it's a certain amount of ohms, whether it be meg ohms or milliohms. And you prefer that to manufacturers' specifications for the ranges those should be in. And then for the breaker testing, results from testing that short term, that long term, instantaneous and ground, you're looking at the amount of seconds it took to trip and the amount of time it took to trip. And again, first place to double check that against or compare that against is manufacturer's specifications for that breaker. Next place could be the breaker curve for determining when that breaker should shut down in correspondence with the other breakers that it's in operation with. Those are the couple of primary areas of what to compare the test results against in order to determine if further action needs to be taken on replacement of those breakers. Some other things can also come to light while testing a breaker. Perhaps a breaker may trip and perhaps not reset. That is a faulty breaker. That breaker needs to be able to reset, and that can happen to breakers over time. They can trip and not reset. And that's a good thing to find so that you know about it in a controlled environment as opposed to 3 o'clock in the morning on a Saturday when the plant goes down and then you need to respond and try to figure that out. Inversely, the breaker might not trip during testing, thus indicating it's not providing any sort of protection. If it's not tripping when it should, it's not protecting the equipment downstream. So knowing that, and again, being able to act upon that in a planned approach as opposed to an emergency response is a much better way of being able to deal with some of those issues.
Absolutely. Well, thank you so much for your insights today, Adam.
Not a problem. Happy to share.
That's all for today's Feed and Grain chat. If you'd like to learn more about NFPA 70B compliance, visit Interstate's website at interstates.com. And if you'd like to see more videos like this, subscribe to our YouTube channel, sign up for the Industry Watch daily e-newsletter, or go to feedandgrain.com and search for videos. Thanks for watching, and we hope to see you next time.